Hi, my name is Sylvain Marron and I am going to show you remote controlled Heli mechanics. First of all, I would like to say sorry for my bad English and my bad accent. I hope you will understand me. Well, this PowerPoint is for beginners who want to know the RC Heli mechanics. Maybe you have seen my previous PowerPoint about RC Heli aerodynamics, which explains main rotor and tail rotor. In this new PowerPoint, we will see in the first part other Heli components, in the second part we will see electronics, and finally we will see electric Heli because there are more and more on the market and on the field. First part is about mechanics. We will see the following components: the clutch, the main gear, the tail rotor drive, and the swash plate. The clutch. Here is a side view of an RC Heli. Clutch is here, between the engine, below, and the main gear, here. The clutch allows to start the engine without driving the rotor. This is a safety component. It's a centrifugal clutch. So, main rotor is driven when engine accelerates, and main rotor is not driven when engine idles. So, we can move the Heli when the engine idles from the starting area to the takeoff area with safety. One note: electric Helis don't have a clutch because electric motor can be stopped or run with the transmitter. Now the main gear. Main gear is here. This is a gray component here. It drives the main rotor. Below there is another smaller gear which drives the tail rotor. Main gear drives the main rotor. A tail drive pellet is mounted just below. This assembly is mounted on a one-way bearing. Then, when the engine runs, it drives the rotor. When the engine idles or stops, the main rotor turns freely. It's like a bicycle, for example. When you pedal, you drive the wheel. If we stop pedaling, the wheel continues to turn. This is the same for the main gear. Now let's talk about tail rotor drive. There are two ways to drive the tail rotor: the belt drive. The belt goes through the tail boom, or the torque tube drive. Torque tube is inside the tail boom too. Here is a comparison about the two systems, with advantages and drawbacks for each system. So, for the belt, advantages are: we have fewer mechanical parts, then it's inexpensive, and we have less damage in case of crash. Drawbacks are: we have a less accurate rudder than with the torque tube, and we need to regularly check the tension of the belt. For the torque tube, the advantages are: we have a precise rudder and we have no maintenance. Drawbacks are: torque tube is more expensive and it's fragile in case of crash. In green here, it is the most popular system that we find now on the new helicopter kits. This is the torque tube. The last component we are going to see now is the swash plate. The swash plate is located here. It controls the pitch of the main blades. Swash plate transmits orders to the main rotor. It can move up or down. This is the collective pitch control. This control makes helicopter move up or down. Or the swash plate can tilt. This is a cyclic pitch control to tilt the helicopter. There are many swash plate types. Swash plate type defines the layout and the number of servos which operate the collective pitch function. Swash plate type may differ according to the model and the manufacturer. Let's see swash plate types. Types are separated by the number of servos used to control the collective pitch. In other words, servos used to move up or down the swash plate. So we will see the different swash plate types. Here is the swash plate, and in black here are locations of servos which control collective pitch. The first type is H1 with one servo for collective pitch here. The H2 with two servos for collective pitch here and here. The first H3 with three servos, two on the neck, and another H3 with three servos, two on the roll, and the H4 with four servos at 90 degrees, two on the neck and two on the roll. Surrounded with green color is the most used swash plate type. This is the H3 with three servos and two on the roll. It is also named 120 degrees CCPM. CCPM means cyclic collective pitch mixing. Now let's see a comparison test between the different swash plates. Let's start with the H1, one servo for the collective pitch. Advantages of the H1 is we have one servo per function, so setup is simple, and we no need of electronic mixing. In other words, we no need a specific program in the radio to manage this swash plate. Drawbacks are servos have bigger load because servos work alone for each function. Also, if we have one faulty servo, we lost one function. So during the flight, if we lost a servo, we will lost one function, the neck, or the roll, or the pitch. Also, one drawback is mechanical mixing. We need mechanical mixing with this swash plate. So the Heli mechanics is more complex. Now let's see the H2. I didn't see advantages. For the drawbacks, we need same servos for identical speed and torque, because servos will work together. Also, we need a mechanical mixing plus an electronic mixing. So electronic mixing means we need to have a transmitter capable to manage H2 swash plate. Now let's see H3 swash plate. Advantages are we don't need mechanical mixing. Then electronic mechanics is simpler. And load is shared by 3 servos because they work together. Drawbacks are we need same servos for identical speed and torque because they work together, and we need an electronic mixing, so we must have a transmitter capable to manage the H3 swash plate. Now the H4, the advantage for the H4 is the safety, because we have 2 servos per function. So if one servo is broken, we have another servo to manage the function. Drawbacks are we need same servos for identical speed and torque because all servos work together. We need an electronic mixing, so a transmitter with a program to manage the H4 swash plate. And also the problem with H4 is that some servos might bind, because it is hard to put 4 points in the same plane. H3 is better for this reason. There is always a plane which contains the 3 points. The row in green is the most used swash plate type, H3 CCPM, because we can have a simpler mechanics, no need of a mechanical mixing, and almost all transmitters can manage CCPM swash plate. Now we are going to talk about RC Heli electronics. We will see governor, gyroscope, and flybarless system. So governor is not necessary to fly, but gyroscope is necessary. Flybarless is an evolution for electronic management of the rotor. Let's start with the governor. So when we modify pitch on the blades, load on the rotor changes, and then the rotor speed changes. To avoid this, we can use a governor. The governor will maintain a constant rotor RPM. How it works? The sensor measures the engine speed, and the governor controls the throttle servo. And even on some Helis, the governor can also control the mixture. How we connect the governor? Here is the magnetic sensor to measure the engine speed. It is connected to the governor. Receiver receives orders from the pilot, and servos control the engine of the heli. Governor is connected between the receiver and servos. Servos are connected to the output of the governor, because governor will give order to them. And inputs of the governor are connected to the receiver to receive order for mixture and speed. For example, the pilot can set a value, for example 2000 RPM for the rotor speed, and also we have the throttle input. This input is to control the throttle servo when governor is disabled. For example, when we start the engine or when we take off the heli. Now, let's see gyroscope. Gyroscope assists the pilot for rudder control. Also, it holds a specific heading regardless of conditions, torque variations and crosswind. Let's see an example. Without gyroscope, the heli is moving forward with crosswind. Then the helicopter is pushed by the wind. Also, the nose of the heli goes against the wind. This is the weather van effect. With an headlock gyroscope or head hold in the same configuration, the helicopter is moving forward and there is crosswind. The helicopter is only pushed by the wind, but it keeps the same heading. Gyroscope manage this. How to connect the gyroscope? Same as the governor, gyroscope is connected between the receiver and the rudder servo. Inputs are gain and rudder control from the pilot. Output is rudder command. The gyroscope detects an angular velocity, so it detects when the tail drifts. Gain allows to set the gyroscope sensitivity. Let's see gyroscope operating. We have two cases. First case, the gyroscope compensates for unexpected tail drift. When the gyroscope detects tail drifting and there is no order from the pilot, then gyroscope generates a control signal to maintain the head in the same direction. So it controls the rudder servo to keep the head constant. The other case is when the pilot sends an order to the rudder. The pilot uses the transmitter and sends an order to the receiver, and the order comes to the gyroscope, and the gyroscope simply transmits the order to the rudder servo. Now, let's see the flybarless system. This is a new feature for RC Heli. It controls the rotor. So, the rotor has no flybar. Rotor is controlled by electronics. Flybarless system is a 3-axis gyroscope, so it controls all functions except throttle. Okay, it will control the nick, the roll and the pitch. And also, we don't need the gyroscope seen previously anymore, because the flybarless system will also control the rudder. How to connect the flybarless module? Here is the flybarless module. Here is the receiver and here servos. The flybarless module is connected between receiver and servos. Inputs are connected to the receiver, gain, rudder, pitch, nick, roll, and outputs are connected to the servos for the rotor and to the servo for the rudder. So flybarless module will emit command for each servo. Here is a comparison of two rotors, one with flybar, the other one without flybar. Here are the main blades, and here is the flybar with the paddle. We see that the flybarless rotor has less parts than the other, and its mechanics is simpler. Now we will see a comparison test between the two rotors. First, the flybar one. The advantages of the flybar is it's inexpensive and setup is simple. Drawbacks are the mechanics is more complex. We just saw that. It is less precise than the flybarless system. We have more drag, it's heavier, and it's fragile in case of crash. Now the flybarless system. The advantages. It's more precise. We have fewer mechanical parts, so we have less drag and lightweight. Also, we have less damage in case of crash. And it's more aesthetical because we have no flybar. Drawbacks are we need digital servos for speed. We have more electricity consumption because it's managed by electronics and we control directly the main blades and not the flybar, so it's more expensive in current. It's more expensive also, and we have a more complex setup. So the flybarless is highlighted in green because it becomes a trend on the new Heli. Now let's see the third and last part, electric helicopters. So I'll talk about electric helicopters because they are more and more popular. Nowadays, electric helis are as powerful as nitro helis. This is due to brushless motors and LiPo batteries. This is a revolution for electric models. Brushless motors have less consumption than other motors. They are powerful and they have no maintenance. LiPo batteries can give high power, have high capacity, and are lighter. So we have lightweight Heli for small and medium models. It is less significant for big models because we need 2 battery packs inside. Now let's see the equipment needed for an electric Heli. We need one brushless motor, a powerful motor that can accept high current. We need one electronic speed controller which can accept high current too, and most of speed controllers have a built-in governor mode feature. Also, we need LiPo batteries with high discharge current. Classes. For electric helicopters, we have many classes depending on the size of the heli. So, we have the 700 class for 700 mm blades length. It corresponds to the 90 size nitro model. We have the 600 class with 600 mm blades length. It's equal to 50 size nitro model. And we have the 550 class with 550 mm blades. It's the same that than the 30 size nitro model. And for the following classes, we will see that the number of the class doesn't match with the length of the blade. So the 500 class have 425 mm blades, the 450 class have 325 mm blades, and the 250 class have 205 mm blades. There are also some smaller classes, like the 100 for example. Here is a comparison of the size of the Heli depending on the class. So here is a 600 class, here it's a 500 class, here it's a 450 class, and here is a 250 class. Now, this is just a comparison between electric and nitro Heli. So, for nitro Heli, advantages are the time of flight. We have more time because we can put fuel when we want, and it looks more real because we have noise and smoke. Drawbacks are it's noisy, it's dirty too, we have to clean up after each flight, fuel is expensive, also nitro engine generate more vibrations, and also engine might stop during the flight. For electric, advantages are we have less vibrations, it's quickly ready, it's plug and fly, it's quiet, clean, and we have no engine mixture adjusting, and motor doesn't stop during the flight. Drawbacks are LiPo batteries are expensive, and the time of flight is short. With a pack, we will fly, the time of the flight will be about 5 to 7 minutes. So, as you can notice, I didn't highlight any row, because every person has its own preferences concerning the choice between nitro and electric. Well, this is the end of this presentation. Thank you for watching. I hope you didn't suffer too much because my bad English and you understood me. So you can find this PowerPoint and other information on my website. Thank you. Bye.